Hello everyone, in this video we'll be looking at how to do this graph question over here on the different solubilities of compounds. Right, we'll be skipping over straight to part B. Part B, which compound in graph 1 cannot be purified by crystallization. So first, we need to think crystallization. What type of compounds can be what type of substances can be purified by crystallization? So crystallization can only be separated by solid liquid mixtures. That means the solid need to be soluble as well, a soluble liquid mixture. So only then can crystallization happen. Okay, that's one. So let's look at graph 1. So over here, when we let's look at the triangle. Okay, calcium hydroxide. Calcium hydroxide is insoluble, so it cannot form a solution. So that's the first one. Calcium hydroxide cannot be purified by crystallization. Right. The next thing, crystallization is a process in which that you heat up the liquid first, and then you try to dissolve as much as possible, and then you let the liquid cool down. Let's look at the next one. We have cerium sulfate, which is this guy over here. So you can see that if, let's say, for example, I do crystallization with cerium sulfate, what is going to happen is that I'm going to first heat up the solution to 80 degrees and try to dissolve as much cerium as possible. So cerium sulfate, I can dissolve about 2 grams here. Okay. And then after that, when I cool it down, I can only dissolve 2 grams, right? Anything else that I add in cannot dissolve. So then, when I cool it down, how come suddenly I can dissolve more? So when this happens, there will be no crystallization. Okay, so cerium sulfate also cannot do crystallization. Actually, the best substance here to do crystallization would be the barium hydroxide. If you can look over here, barium hydroxide at 80 degrees Celsius can dissolve 100 grams. So you dissolve 100 grams inside at 80 degrees Celsius, and when you let it cool down, suddenly the solubility drops, and then around at room temperature, only 2 grams can dissolve. So that means this whole part over here will crystallize. Right? So the best will be barium hydroxide. Not so good will be these two. Not so good. Right? But what cannot be purified by crystallization would be this is circle, so cerium sulfate, and then triangle, calcium hydroxide. Right? How do we write our explanation then? So first we have calcium hydroxide, and the reason why calcium hydroxide cannot be purified by crystallization is because calcium hydroxide is insoluble and it forms a suspension. Alright, the other one is cerium sulfate. And why cerium sulfate cannot be purified by crystallization is because cerium sulfate solubility actually decreases when temperature increase. So these two substances, calcium hydroxide as well as cerium sulfate, cannot be purified by crystallization. Okay? Alright, now, next question. Describe how a mixture of barium hydroxide, calcium hydroxide, and magnesium chloride can be separated. So I mix them all together, and then I want to separate them. So let's take a look. So we have barium hydroxide, which is, let me highlight in purple, barium hydroxide. And then we have magnesium chloride, which is this one over here. Right? As well as calcium hydroxide, which I'll highlight in red. which is this one over here. So how do we separate these three substances? Right, so I just want to number it off. I want to number this 1, I want to number this 2, and I want to number this 3. So first, we can see that number 1, right, is insoluble. So anything that's insoluble, number 1, can be separated by filtration. We add water and it doesn't dissolve, right? Because it doesn't dissolve, right, you can filter it out. Next, you can see that the purple line, number 3, right, actually when you dissolve it in water, 25 degrees, it also cannot dissolve very well. If you look over here, right, it cannot dissolve very well. So before I do the filtration, I need to add water, right, to make sure that number 3 and number 2 dissolve. So what temperature water should I use? Right, obviously I need to use a high temperature water to make sure that 3 and 2 will all dissolve. Okay, so now let's say I add water. So step 1, right, step 1, I add 80 degrees Celsius water. When I add the 80 degrees Celsius water, what happens at 80 degrees, number 3 and number 2 will dissolve, but number 1 will not dissolve. So then step 2, what will I do? I will filter. And then I will collect number 1 as residue and number 2 and number 3 as filtrate. So now I have number 2 and number 3 as a filtrate. How do I get them separated? So if you see, if I cool number 3, the solution down all the way to room temperature, right, number 3 will crystallize first, but number 2 will not crystallize. So what will happen? Step 3, I will cool filtrate, right, to, let's say, room temperature. So then I'll get my crystals of number 3. So what do I do when I get my crystals? I need to filter again. So I need to filter to get number 3. And then number 2 will still be in solution. So after that, I need to evaporate to dryness. Alright, so this is just in point form, but please write it clearly so that we can see how to separate number 1, number 2, and number 3. Okay, so I hope that has been helpful for you. Alright, bye-bye.